What did we talk about yesterday? Very good. We solved our systems of equations by graphing. How did we solve by graphing?
Drawing two lines.
Draw two lines. We graphed our two lines on the same graph. What was my solution?
Where they meet.
The point where they intersected. The ordered pair where they intersected. What if I had parallel lines?
No solution. No solution.
There was no solution because parallel lines will never intersect. What if they're the same line?
Infinite.
I had an infinite number of solutions. So infinitely many solutions because they overlap at every single point. Any questions about yesterday? What we did yesterday? Okay, the second way we're going to solve systems of equations is by substitution. So here's our steps right here. The steps are on your sheet of paper. Step 1, solve one of your equations for x or y. We want to get one of the variables by itself. Substitute the resulting equation from step 1 into the other equation for that variable. So when we solve one of our equations for x or y, that variable will be by itself, correct?
Yes, sir.
So I have y equals 3x plus 5. I can substitute the expression 3x plus 5 in for my y variable, because that's what y equals, right? Does that make any sort of sense? Okay, hopefully it'll make more sense when we look at the examples. Okay? Whenever we plug in, we can solve for the variable, because we'll just have an expression or an equation in one variable. And then the last step is substitute your answer from step 3 into either original equation to find the other variable. Yesterday, what was my answer? How many values did I have in my answer? 2. I had an x value and a y value, right? Same thing today. I have to find my x value. I also have to find my y value. So my answer is still going to be an ordered pair. Does that make sense? Because we're still dealing with the systems of equations. We're just looking at another way of solving them. So everyone has the steps down, right? Because they're on your sheet of paper. Are we ready to move on to my first example? Okay, moving on. We have y equals negative 7x minus 1. Y equals x minus 9. What does step 1 tell me to do? Yes?
Substitute y with x minus
9. What does my first step tell me to do, though?
Solve one of the equations for x or y.
Solve one of my equations for x or y. Are any of my equations already solved for x or y?
Yes.
Yes, they are. So I don't really have to do step 1, do I? It's already done for me. What does step 2 tell me to do?
Says.
Backtrack. How can you tell if that was already done?
Do I have one of my variables isolated on one side of the equation?
You mean as in like 7x or like y equals? Like what do you
I just want it to be y equals some expression or x equals some expression. Right? There's no other numbers with my y or my x, right? In this case, it's my y. Both of my equations are solved for y, right? So that helps me out a lot. Does that make sense? Okay. Okay, what did step 2 tell me to do?
Step 2 says substitute the resulting equation from step 1 into the other equation for that variable.
Very good. I'm substituting my result from step 1 into the other equation. So Kyle, what did you tell me to do now?
Substitute y with x minus 9.
Very good. In this case, I've got y that equals x minus 9, right? Equals means they're the same. That means I can substitute them for each other. They're interchangeable. So in my other equation, I can replace this y with what? X minus 9. Does everyone see that? Yes?
You should also just do it the other way around.
Yep. You could do it the other way if you wanted to. because y also equals negative 7x minus 1. So I could plug negative 7x minus 1 into this bottom equation if I wanted to. Either way is going to work. I'm going to get the same answer. Does that make sense what I've done so far though? Since y equals x minus 9, I can replace y with x minus 9. Everyone understand that concept? What does step 3 say? Solve for the remaining variable. What's my remaining variable?
X.
X. I'm solving for x. So what would be my first step here to solve for x?
Add 9.
No.
No.
Subtract x.
So if I have variables on both sides of my equations, do I want to move my variables first or my constants? Variables. Why do I want to move my variables first? So I can get them on one side, but I also want to see if my variables will cancel each other out before I do anything else. That's why I always tell my students, move the variable first. Sometimes it'll cancel out for us, sometimes it won't. So let's get our variables to one side. How do we want to do that? Add 7x to both sides. It'll cancel out over here. Whatever I do to one side, I have to do to the other. X plus 7x. 8x. Minus 9 equals negative 1. Now what can I do? Now I'm going to add 9 to both sides. After I get my variables to one side, I'm going to move my constants to the opposite side of the equation. So I get 8x equals, what's negative 1 plus 9? 8. And what is my last step? Divide by 8 on both sides. What does x equal? 1. Am I done?
Yeah. Oh, you gotta check it.
I don't have to check it.
Identify.
Got to substitute it back into one of my original equations because I just found x. What else do I have to find? Y. So in my ordered pair, does 1 come first or second? First. My first value is always my x value. So there's half of my ordered pair. Does it matter which equation I plug back into? No. I can pick either one. So which one do we want? The first or second one? Second. So y equals 1 minus 9. What's 1 minus 9? Negative 8. Now am I done? Very good. I do want you to write your answer as an ordered pair. I don't want you to leave it as x equals 1, y equals negative 8. I want it in ordered pair form. That way you can show me that you know how to write an ordered pair. Which value comes first, which value comes second. Everyone okay with that? Now if I wanted to check my solution to make sure it was okay, what would I need to do?
Plug it in.
Plug what in?
The numbers.
Which numbers?
1 and negative 8.
1 and negative 8. I'd have to plug both numbers in to both of my equations and make sure it works for both of my equations. We're not going to do that today though, okay? Questions on this problem right here? Does that kind of ring any bells from Algebra 1 at all? A little bit? Did it make sense if it didn't ring bells? Okay. Let's move a little quicker through the next few examples. Number 8. Do I have an equation that's solved for one of my variables? Which one? Y. My top one's solved for y, right? I know y equals negative 5x plus 30. So what variable in my other equation can I replace with negative 5x plus 30? Y. So I'm going to rewrite this equation exactly the same, except when I get to y, I'm going to plug in negative 5x plus 30. Does that make sense what I've done so far?
Will we do those for other ones, like for number 10? Not number 10, never mind. We don't have to.
You okay? Okay. So now I'm just solving for x. What's my first step? Distribute. Three times negative 5x. What? Negative 15x. 3 times 30. Positive 90. And then I still have my equals 42. Everyone with me still? 7x minus 15x. Negative 8x. Plus 90 equals 42. What's my next step? Subtract 90 from both sides. Am I moving too fast for anyone? 42 minus 90. Negative 48. Last step. Divide by negative 8 on both sides. So x equals
6.
positive 6. Which value is that in my ordered pair? First or second? First. Okay. Which equation do we want to plug into? First or second? First.
Oh, darn.
If you already have an equation solved for one of the variables, I'd probably plug into that one because it's already solved for y. Oops. Golly, quit that. So I get y equals negative 5 times 6 plus 30. What's negative 5 times 6?
0.
Negative 30. Negative 30 plus 30? 0. Can my answer be 0?
Yeah.
Yes, it can. Once again, please write your answer as an ordered pair. So my answer for number 8 is 6, 0. Are there any questions on that? Making sense? Kind of a lot of work, but once you kind of get into the groove of things, it goes kind of quick. Okay? Can I move on? Here we go. 6x minus 5y equals negative 28. 7x plus y equals 22. Do I have an equation solved for one of my variables? I do not. None of the variables are by themselves on one side of the equation. So now I actually have to do that first step. I've got to solve one of my equations for one of the variables. Which equation and for which variable is going to be easiest to solve?
Second.
Second one for which variable?
Y.
I'm going to solve for y. Does everyone see why that's the case?
Is by itself?
Do what?
Is by itself?
Because the y is by itself. I'm only going to have to do one step to get y by itself. What is that one step?
Subtract 7x on both sides.
Subtract 7x from both sides. So what does y equal?
22. Minus 7.
Negative 7x plus 22.
Y equals negative 7x plus 22. Now, I've got an equation solved for one of my variables. Now I can just plug what into my other equation for which variable?
Y.
Plugging in for y, but what am I plugging in for y?
7x plus 22.
Negative 7x plus 22. Y equals that expression, so I can replace the y in my other equation with that expression. Everyone got that? So 6x minus 5 times negative 7x plus 22 equals negative 28. What's my first step now solving for x? Distribute. Negative 5 times negative 7x. Positive or negative? Positive 35x. Negative 5 times 22. Negative 110. Everyone's still with me? What's my next step? Do what? Combine my like terms. So I've got 6x plus 35x. What does that give me? 41x. Okay, what's the next step? Add 110 to both sides. Let's move our work up here. 41x equals, what's negative 28 plus 110? 82. And my last step, divide by 41. So x equals 2. Questions there? Can I erase my work right here so I can have more room?
Yes.
Any questions so far? Now I've got to figure out which equation I want to plug into. I now technically have 3 equations that I could pick from. My 2 original ones, and then the one that I solved for y. I can use that equation because it is equivalent to the one I solved for. So which equation do we want to use? First, second, or third? Third, because it's already solved for y. So I'm plugging 2 in for x. Negative 7 times 2. Negative 14. Negative 14 plus 22.
8.
Positive 8. So what's my ordered pair? 2, 8. Questions on number 9? I see her get shut up. Questions on 9? Do we just have 10, 11, and 12 left? Okay. 10. Which equation am I solving for which variable?
X.
X, which equation?
The top one.
Top one, very good. X doesn't have a coefficient besides 1, does it? So once again, I'm just going to have one step to get that variable by itself. So what's that one step? Add 7y to both sides. So we get x equals 7y plus 53. Now do I have an equation solved for a variable? Yes, I do. Okay, this is different than the ones we've done. All the other ones were solved for y, right? This one's solved for x. Does my concept change at all? Still the same concept. I'm just replacing x with an expression instead of y this time. X equals 7y plus 53. So I can replace this x in this other equation with 7y plus 53. Does everyone see that? So we get negative 4 times 7y plus 53 minus 5y equals 19. Any questions about that at all? first step here? Distribute. Negative 4 times 7y. Negative 28y. Negative 4 times 53. Negative what? Negative 212. Question?
I put in 5 instead of 4.
Oh, okay. And then I have my minus 5y equals 19. I've got some like terms. What do I get when I combine those?
Yeah.
Negative 33y minus 212 equals 19. Next step. Add 212. Oops, not 219. Add 212. Negative 33y equals 231. Last step. So y equals negative what? 7. So I found my y variable. What do I need to find next?
Your x variable.
Got to find x. Can I erase my work?
Yes.
Yes. Once again, we've got 3 equations now we can pick from. My 2 original and the one that's solved for x. Which equation do y'all want to use? The one that's solved for x. So plugging in negative 7 for y and working it down. 7 times negative 7.
Negative 49.
Negative 49. Negative 49 plus 53. Positive 4. So what's my ordered pair? 4, negative 7. How do I want your answer?
And ordered pair.
As an ordered pair. Do not leave it as x equals 4, y equals negative 7. Can't repeat that enough. My last 2 examples, can I move swiftly through them and not ask you guys a whole bunch of questions?
Please do.
Okay, let me give you a calculator so I didn't have it with me. We'll fly through these, okay? 2y equals 6x plus 10. 3x minus y equals 5. I'm going to solve my top equation for y. Divide by 2 all the way around. You get y equals, goodness gracious,
Going too fast.
y equals 3x plus 5. I now have one of my equations solved for a variable. Y equals 3x plus 5. So I'm going to replace this y with 3x plus 5. What number is understood to be there in front of that parentheses?
1.
1. It's a negative 1, right? So I have to distribute this negative 1 through my set of parentheses. So I get 3x minus 3x minus 5 equals 5. Everyone okay with that? Okay, when I combine my like terms, 3x minus 3x, that gives me 0. They cancel each other out. What am I left with? Negative 5 equals 5. Is this a true or false statement?
False.
False.
No solution.
What do you think my answer is?
No solution.
No solution. Does that make sense? If you're trying to solve for one of your variables, all your variables cancel out. You're left with a false statement. I get no solution. Does that make sense?
Yes.
So what kind of lines are these?
Parallel.
Parallel. They're never going to intersect. I'm never going to have that intersecting point. Any questions on that? Okay. Last one. 5x plus 7y equals negative 17. 4x minus 3y equals negative 5. I'm going to solve one of my equations for one of my variables. Neither one of these looks very fun to solve for either variable, so I'm just going to solve the bottom one for y. Subtract 4x. Negative 3y equals negative 4x minus 5. Divide both sides by negative 3. Y equals negative 4/3 x. Actually, it's a positive 4/3 x. Getting ahead of myself. Plus 5/3. I can replace y with 4/3 x plus 5/3. So we've got 5x plus 7 times 4/3 x plus 5/3 equals negative 17. I'm going to distribute here. 5x plus 28 over 3x plus 35 over 3 equals negative 17. Everyone with me? Yes?
25 or 30?
This is a 35.
Where did you get fraction from?
I multiplied 7 times 4/3. So that gave me 28 over 3. I multiplied 7 times 5/3. That gave me 35 over 3.
I mean, like, from the beginning. How did you get?
You divided.
So I was solving my bottom equation for y. So I subtracted 4x from both sides. And then I had to divide by negative 3. So negative 4 divided by negative 3 would give me some decimal. So I kept it as a fraction as 4 over 3x. Same thing with negative 5 divided by negative 3. That gave me some nasty decimal. I kept it as an improper fraction. Does that make sense? A little bit. Okay, combining my like terms. 5x plus 28/3 x. (43 over 3x) plus 35 over 3 equals negative 17. Subtract 35 over 3 from both sides. Negative 17 minus 35 over 3 gives me negative 86 over 3. Now I'm dividing both sides by 43 over 3. Negative 86 over 3 divided by 43 over 3 gives me negative 2. Questions where I got my x from?
No.
But guess what? I'm not done. Because now I have to get what?
Y.
Got to get my y value. So I'm going to plug negative 2 in for x. I'm going to use this equation right here. Y equals 4/3 times negative 2 plus 5/3. That's going to give me negative 8 over 3 plus 5 over 3, which gives me negative 3 over 3, which gives me negative 1. So let's write our answer up here. What do we get for our answer? Negative 2, comma, negative 1. There is my ordered pair, my solution. Any questions on number 12? Any questions on any of these notes we just took? Follow the steps that are on your paper. Step 1. You okay? Ready for the assignment? Step 1.
Don't.
Solve one of your equations for one of your variables. So get y by itself on one side of the equation or get x by itself. It doesn't matter which one. You can do either one. Step 2. Take that expression from step 1, plug it into your other equation. So you get an equation in one variable. Step 3. Solve for that one variable. Step 4. Plug that variable back into an original equation. to get your other variable? Any questions about any of those steps? Or any of the examples we did? Does it matter which variable you solve for first? No. How do I want your answer?
Ordered form.
As an ordered pair. Right?
Yeah.
Do I want you to show all of your work?
No.
No.
Yes.
Do I want you to show all of your work?
Yes.
Yes, I do. Show all your work.
On the assignment.
Show me how you plugged in, where you plugged in. Write your answer as an ordered pair. Box in your ordered pair for me. Are there any questions about anything we just covered?
No, sir.
No?
No.
For sure. Now's a good time to ask questions.
How do you know which?
Do what?
Never mind.
No, go for it.
No, I think you already answered that question.
Ask it again just in case.
How do you know which is the accurate way to start for a certain one?
Some of them, there will already be a variable solved, like on our first few examples. That's where I would start. I would use that equation that was already solved for a variable. In this case, we used y equals negative 5x plus 30. Right? That's not always going to be the case, is it? In this case, I just look for the variable that might be the easiest to solve for in a certain equation. In this case, it was y in my second equation. Because y didn't have a coefficient, did it? So I just had to do one step to get it by itself. So that's where I would start. Let's look at number 12. None of my variables looked very fun to solve for. So I just picked one and went with it. Okay? So it just depends on what you're given. Does that make sense? A little bit. Okay. Any other questions? It's a good question. Any questions before I end my recording?